Okay, everybody, let us open up the ICP files and get the concentrations and the standard deviations from these guys. All right, so we're going to browse for these files, and they are on Canvas right now, so you should be able to find them. And what we can do is look for the look for all file types here. And you should be able to find your data as a CSV file. So these are ICP data Wednesday files, for example, and I'll pick file number 4, and I will open this guy. And sorry, that actually came up with a different Excel window, but I will change it for this one right here. And first thing it does is tells you to save it as a different file type. So we can save it as an XLSX file, like so. And then we are going to get rid of a lot of extraneous columns here. And I'm right-clicking on the letter. And you can see most of them are extraneous. It's okay. Then all of these to the end are extraneous to our goal right now of getting the concentration and the standard deviation. Oh, and we don't want the corrected concentration either, so there is no correction. So we do this, and then we want to sort by the element type here. So we're going to do a custom sort here, and the custom sort will be on element. It's going to use this column to sort the entire data file, and here we go, we do that. And now we have blank through sample for calcium, iron, magnesium, and zinc. So next thing we want to do is add a few lines here to separate these out. Just going to insert a couple of guys here, and that looks good. Alright, so now we've got some cosmetics to do here. First of all, we're going to take this value here, and this is the calculated concentration that the software got. And I'm actually going to put this guy up in the corner. Let's say, okay, that's fine. I get it. Actually, I don't get it. Let's put this up here. And let's put this guy up here. And then this guy up here. Now I'm going to put a 0 in that cell because when we make the standard additions plot, that is what goes there. Because this is the plot point for 0 moles added. Okay. Now here's a blank. That's a very small number compared to that, but we might as well correct for it. So in this case, we're going to have this cell is going to equal this cell minus this cell. We don't want that guy to change, so we're going to press F4 there. Okay. I'm going to copy this guy down here. And then do the same thing here. All right, save that. And now we're going to linnest all this stuff. 3 3, 4, 5, 1, 2 equals the nest of the y values will be here, the x values will be here, the constant will be true, and the stats will be true. Shift, Control, Enter. We've got the nest. Now we need just a couple of other things here. We need an average, or a dev square. This is going to equal the average of these guys. And this is going to equal dev square of these guys here. Oops. There we go. Brilliant. So now we've got C equals equal to B divided by M. This thing's under control there. And S sub C equals a new value for which I'm going to grab the formula right now. And here's the formula for SC. Put that guy right there. Okay, so this guy is going to equal the square root of a bunch of other stuff. And that bunch of other stuff is going to have three terms. One term times a second. That second term is going to have one term plus another. And that last term is going to have y bar squared over m squared, which is that guy, times sxx, which is the dev square of x. Oops, I lost the, oh wait, no I didn't. E7 over G2. There we go. Now the second term there is going to have, it's going to be 1 divided by n, and n is the number of cal points here, and that is going to be 4. And the square root term, and this first term times everything is going to be sy, which is this guy, squared divided by m squared. That gives us an S sub C of 3. 3.0. I'm going to trim that guy down to size. And there we have it. This is how to get the concentration and the standard deviation in the concentration. The concentration is slightly different from the value derived by the software, but I have no reason to doubt that this is the proper way to do this. Alrighty, good hunting, and I will follow up with another video on how to do the propagation of this through the sample prep to get the milligrams per tablet, and then the uncertainty in the milligrams per tablet.